Okay, so we have to have a little discussion about what kind of exceptions you should typically catch, as opposed to other types of exceptions that you should handle differently, meaning not with try-catch blocks. And this might be surprising to some of you. But basically, okay, so we have a kind of a picture of the family tree part of the Java class library that deals with exceptions. Kind of the grandfather of this branch of the family tree is throwable. And from there it branches into two very distinct categories of exceptions. Errors and exceptions, okay? And then, this is the cosmic superclass way up at the top of the family tree, like kind of the original object, way up there, okay? So let's take a look at these two branches here. So this branch error, these are exceptions that you would not catch, okay? These are catastrophic failure, like systemic failures. For example, hardware issue, maybe you ran out of memory, or maybe the operating system failed in some way. So these are completely out of your control as a programmer, all right? On the other hand, this side of the family tree has exceptions that you will be thinking about and anticipating and possibly catching in your code. Now, these are divided into two categories in and of themselves. These are called checked exceptions versus unchecked exceptions. Checked meaning the compiler checks them at compile time. Like you have to catch these. You have to do these in try-catch blocks. I didn't do one of these in the last program. Okay. I did not have a checked exception in that program, the body mass index program. Often you'll see these related to I/O, like input-output type of operations, file I/O. For example, like your program requires an outside resource like a file, but the file's not there. That would raise maybe a file not found exception, or maybe the file is there but it's not in the right format, or it's corrupt or something. That would raise another type of, I/O type of exception. These you do have to catch. The compiler won't let you get away with not catching them. Okay, so the compiler is checking for these at compile time. Unchecked exceptions are, the official Java stance is that you should not catch unchecked exceptions. Now here's the thing. The last video I did with the body mass index, when I caught number format exception and I added my own custom exception, those are unchecked exceptions. So I really should not have done that. According to Java, that was kind of shoddy programming practice of me to catch those exceptions. Here's the thing. You can write your code in a way that it is so robust that those types of exceptions would never be thrown in the first place. Okay. And that's how I should have done it. Not with a try-catch block like I did. Now, we're gonna do, and I'm not saying that you'll never see a professional program that catches a number format exception. You will. I think a lot of this, like this advice, like the official Java stance about unchecked exceptions and not catching them, that probably originates from a long time ago when computing resources like memory were scarce, much more scarce. So like today, memory or system resources is much more abundant. And the thing is, exceptions are very expensive to throw and deal with, like as far as, system resources. So that's probably kind of a throwback to the old days when everybody was scrimping and scrounging for every byte of memory. Now things are more relaxed. So you probably will see people catching number format exceptions. But you can write your code in a way that it's so airtight that that exception is never going to be thrown anyway. And I'll show you an example of that. Before I do, I'll show you this is a variation. So it's kind of a more detailed version of the diagram I just showed you. And so we have that branch of the family tree that deals with exceptions. The checked exceptions, which you should catch, which you have to catch. The compiler's checking for them and it's making you catch them. Those are in pink. And then everything else, the unchecked exceptions, are in green. Okay, so these are the errors, like the systemic failures I talked about that you have no control over. Okay, so you're not even going to consider those in your program because they're just so out of your control. And then here, this was me in the last video. Okay, me, just catching the number format exception, and, I had a math problem going on, so I did a workaround with my own custom exception. I could have coded that program differently so that that was never a problem to begin with, and that's what I should have done. All right. Again, we'll catch these. We'll catch these in our class because it's just good practice to do these try-catch blocks, and especially the number format exception. That's a really easy exception for students to trigger as they're testing their programs just by entering some garbage that isn't going to parse. So we'll use them. I'm not going to completely, forbid you from catching those types of exceptions, but the official stance is you should not have to do that. So I'll just show you the variation. And I don't think I'm going to talk about this code at length, but I'll post this definitely for anybody who wants to look at it. I put the note at the top basically explaining in a nutshell what I just said in those with those diagrams. But what we have here is the same program, but so here's where I'm just getting the input with keyboard next. I'm getting the height. And before I actually parse it, I have this temporary input. I'm just getting whatever the user entered from the keyboard. I don't know what it's going to be. If it's something I can parse, maybe not. But I have this spiel here, this loop that is going to put in a call to a method I have down below. I coded this. It's down below. Okay, I'll take you there in just a moment. But we're going to run that temporary input through my check method at the bottom, my isValidNumber method. And while they keep getting it wrong, I'm going to keep coming back at them and saying, no, this isn't right. You have to re-enter it. Okay. Only then, when they've cleared this hurdle, am I going to go for the parse. Am I going to actually parse it? Okay. So, and that same thing with the weight. So that was for the height. Same thing with the weight. I get the temporary. I run it through my checker method. And only when I know that it's something that can be parsed, then I will parse it. And then I'm home free. Okay. Also, I don't know about the... Yeah, I don't think I checked for the divide by zero thing. I would have to do a check on that. I mean, that's just an easy if else. If it was zero, then I'm going to, tell them to re-enter it. That was just, I don't have to do a try catch block for that. Just say if it was zero, or if it was zero or less than or equal to zero, then I'll ask them to re-enter. I won't accept that into my program. So anyway, this is the isValidNumber method. It's basically me just picking through a string, one character at a time, making sure it's a digit or a decimal point. If it is a decimal point, I have to make sure it's the only decimal point in the string. So it's just a little bit of finagling here, but ultimately, this will do it. This will do it. So I don't have a single try catch. It's not going to throw a number format exception because I've made it airtight. This is the way you should technically be doing things.